When you talk to an AI, there's often this feeling that something's missing, right? They can be helpful, for sure, but they don't always feel like they truly get it. So I set out to tackle that challenge with my project PsycheSmol. The goal? To build something with real emotional intelligence, but with a twist, doing it all on a really, really small scale.
And that led me to the question at the very heart of this project. Is it even possible? Can a tiny, efficient AI model actually show the kind of real, nuanced empathy that we normally only expect from those giant, resource-hungry systems?
To really understand the solution I came up with, we first have to dig into the problem itself. Why AI often struggles so much with empathy. This quote from my project docs pretty much nails it. We've all seen it, right? You get advice from an AI that's supportive on the surface, but it just feels hollow. It's like it's reading from a script instead of actually understanding what you're going through.
This gap is a really big deal, especially in sensitive areas like mental health support. A generic model might just spit out a bulleted list of tips for stress relief, but what it often misses is the ability to just validate someone's feelings or to help them explore why they feel that way. And that's the nuance that makes a conversation feel real and helpful. It's the part that's usually missing.
So, to try and bridge that exact gap, I developed PsycheSmol. It's my attempt at a small model designed to handle this very big task.
So what is it technically? Well, you can think of PsycheSmol as an experiment in high-precision tuning. The whole point was to take a small model and very carefully train it to have a level of emotional intelligence and therapeutic understanding that goes way beyond what it could do out of the box. And when I say small, I mean really small. This model has just 135 million parameters. Now, to put that in perspective, the big models everyone talks about have billions. But this constraint was totally intentional. It forced me to focus on making the training method smarter, not just relying on the raw size of the model.
So, how did I actually do it? Well, the secret sauce is a two-stage alignment pipeline I designed just for this. Okay, so we start with the base model SmolLM2. The first step is something called supervised fine-tuning, or SFT. Here, I just show the model a ton of high-quality, empathetic responses to teach it the right tone. But the real magic, that happens in step 2, direct preference optimization, or DPO. In this stage, the model doesn't just see a good response, it sees a good one and a bad one, side by side. It has to learn not just what is good, but why it's better.
Now, to make all this work on such a small model, I had to use a really efficient set of tools. Instead of retraining the whole thing, techniques like LoRA let me make very targeted adjustments, and things like quantization help shrink the model's size. This was all managed by some amazing libraries like TRL and PEFT, which let me do all this without needing a giant server farm. And the fuel for this whole engine, that was the PsychoCouncil preference dataset, which provided all those critical good versus bad examples.
All right, so that's the theory. But what did this two-stage process actually accomplish? Let's check out the results.
This table gives you a fantastic snapshot of the model's evolution. The base model, it's neutral, does what you tell it. The SFT model, after that first stage, gets the right tone, but it can still sound a little generic. But the DPO model, that's where you see the real transformation. It learns to consistently pick the more empathetic, more insightful path.
And what's so cool about this slide is that you can actually see the learning happening. Take a look at that top left chart. The blue line is the score for the good responses, and the orange is for the bad ones. As training goes on, the model learns to love the good stuff and hate the bad stuff, and that gap between them just gets wider and wider. And as it does, you can see the accuracy on the bottom left just skyrocket.
And this is where it ended up, a final reward accuracy of 98.84%. That means that by the end, the model could almost perfectly tell the difference between a response that was genuinely helpful and one that wasn't.
And this chart really shows why that training was so effective. The data I used had a crystal clear quality gap. The chosen responses were just miles better across every single metric: empathy, safety, you name it. It's this clear difference that lets the DPO training work so well.
But honestly, charts are one thing. This right here is the ultimate proof. On the left, a user says they're feeling overwhelmed. The base model gives them generic advice about sleep. The SFT model is a bit better, it acknowledges the feeling. But then look at the DPO model on the right. It starts by validating their experience. It's completely understandable. And then it asks these thoughtful, open-ended questions. That's the jump. That's going from generic to genuine.
So what does all this mean for the real world? I mean, this isn't just a fun experiment. There's some serious potential here.
Having a small, efficient model that's also highly empathetic just opens up so many doors. It could run locally on your phone as a mental health assistant, which keeps all your data private. It could lead to safer, more aligned AI for everything from customer support bots that actually understand frustration to educational tutors that can sense when a student is struggling.
And that's really the final thought I want to leave you with. This project makes me wonder, what if we can build highly specialized, safe, and effective AI without needing these enormous models? What if the future is about precision, not just raw power?
If you're curious about any of this and want to dive deeper, check out the code or even try out the model for yourself. The whole project is open source and available on my GitHub. I'd absolutely love for you to take a look.